Welcome to the Explainer. Today, we're going to be talking about one of Python's most essential building blocks, the tuple. Now, you can think of it as a list that's been, set in stone. It's a really powerful tool for making your code safer and more efficient. And hey, if you want to get a handle on more Python concepts just like this one, make sure you subscribe to this channel.
So let's start with a question to get you thinking. Have you ever had a list of data that you just needed to protect from any accidental changes? Things like a fixed set of user roles, or maybe some specific geographic coordinates, or even just the days of the week. You need something solid, something reliable. Well, that is exactly where tuples come in. Okay, let's dive right into what these things actually are. At its heart, a tuple is a lot like a list, but it's got one crucial, unshakable rule that pretty much defines everything about it. So here's the core idea. A tuple is just a collection for storing multiple items. And if you only remember two words from this whole thing, make them ordered and unchangeable. Ordered is simple enough, right? It just means the items stay in the exact sequence you put them in. But unchangeable? Well, that's the superpower we're really here to explore. When we break it down like this, a few things really pop out. A tuple is ordered, just like a list. It can hold different data types, no problem. It can even have duplicate values. But that second point, immutable, that is the real game changer. It means once you create a tuple, it's locked in. It is set in stone. So how do we actually make one of these and get information out of it? Well, it's a lot simpler than you might think. But there is one little detail, a little gotcha, that you have to get right. Making a tuple is actually super easy. Instead of the square brackets you'd use for a list, you just wrap your items in regular parentheses, and you separate them with commas. Simple as that. You've now officially packed those three strings into a single ordered tuple. Now, here's that little trap I mentioned, and it gets a lot of beginners. If you try to make a tuple with just one item and you forget the comma, Python doesn't see a tuple. It just thinks you're putting parentheses around a normal string. It's that trailing comma that explicitly tells Python, hey, pay attention, this is a tuple. It's a tiny detail, but it's absolutely crucial. Okay, so once you have your tuple, getting stuff out of it is exactly the same as with a list. You just use square brackets and the item's index number. And remember, we always start counting from 0. So index 0 gives us our first item, which is apple. And the similarities to lists don't stop there. You can use negative indexing, where -1 always grabs the very last item. You can also use something called slicing to, carve out a specific range of items. Doing that actually creates a brand new, smaller tuple from your original one. All right, let's get to the single most important concept about tuples. This is what truly separates them from lists, and it's what gives them their entire purpose. So what happens if we decide to just ignore the rules? Here we've got our fruits tuple, and we're trying to reassign the item at index 1. We want to swap out banana for mango. What do you think Python is going to do about that? It stops you dead in your tracks. Python throws a type error, and the message couldn't be clearer. You cannot assign a new value to an item in a tuple. The door is locked. That's it. This right here, this is the soul of a tuple. This is what we mean by immutability. It's not a bug. It's not a problem. It is the core feature. It's a guarantee that the data inside that tuple will not be changed after you create it. So what does this actually mean day to day? It means you can't add, you can't remove, and you can't change elements in a tuple that already exists. But, and this is key, you can combine existing tuples to create an entirely new one. See how the original tuples, A and B, they're completely untouched in this process. I know what you might be thinking. This all seems really restrictive, right? Why would I ever choose to use something that's less flexible than a list? Well, it turns out this restriction is actually a superpower. And this is where tuples really start to shine. For fixed data, like the months of the year, they're like a built-in safety net. When a function needs to return multiple values, like, say, x and y coordinates, a tuple is the cleanest, most standard way to bundle them up. And here's a little bonus. Under the hood, because their size is fixed, tuples are often a little bit faster than lists, and that can really make a difference in your code's performance. Okay, now for a really powerful and honestly elegant feature that makes working with tuples super convenient. It's a bit of what we call syntactic sugar that just makes your code cleaner and way more readable. We call this packing and unpacking. Step 1, packing, that's just creating the tuple like we already did. But step 2, unpacking, oh, that's where the magic is. In a single line of code, we can assign the contents of that tuple to a series of individual variables. The first item goes to the first variable, second to the second, and so on. It is incredibly slick. And it gets even better. You can use an asterisk to grab the rest of the items. So here, the first item, 1, gets assigned to the variable a. Then that asterisk tells Python to pack all the remaining items into a brand new list called b. This is just amazingly useful when you're dealing with data and you really only care about the first or maybe the last couple of elements. So when should you reach for a tuple? It's pretty simple, actually. A list is for a collection of things that needs to change, but a tuple is for data that you want to remain constant. It's a choice that really signals your intent as a programmer. So I'll leave you with this final thought. Where in your own projects, right now, could an unchangeable tuple make your code safer, clearer, and just more robust?